Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Yeah, we're good to go. We are good to go. We are good to go. So, core concept account model is done. Uh, Transaction fees, or I guess it is done. Nope, nope, nope. Programs on Solana. What is it? Core concept, it is done. It is also done. I guess. I guess no. I guess no. Okay, let's start from here. I guess we have not done this yet. We have not done this yet. Okay. Okay. So basically, go through this core concept first. We have done the get started part, and um, APIs. Oh my God, still a lot of APIs here. Wow. Okay. Cook. Deployments. Okay. 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 Got you, baby. I got you, baby. Okay. So Solana account model. On Solana, all the data is stored in what is called accounts. Okay, you can think of data of Solana public data within single accounts table. For each entry in the table is account name. Solana account shares the same base account type. Got it. We have done this before. So the key points is account is 4 for 10 MIB. What is this MIB? Megabyte? Or what is this? Let's see. Um, what is, oh my god, what is computer, computer. Shit. Yep. Maybe byte. What is this maybe byte? What is maybe byte? Measurement of the use in computer storage prediction. Oh my god. I was, I was. I was right, so maybe bytes come by the estimate replacement for the two. The maybe bytes of replacement. A maybe bytes equals to the value. Means alright. Right. So which contains either executable programs code or program state. Yep, yep. Accounts require rent, deposit, lamp outs. Okay, I know this also. Every account has a program owner. Yep. Only the program that own the account can change the data and deduct or lamp out balance. But once you increase the balance, but once, but anyone can increase the balance. But anyone, what? Only the program that okay. Yep. No. Only the program that owns an account can change the data and deduct its landlord balance, but anyone can increase. What? What? What the fuck? What the fuck? Only the program that owns. Only the program that owns account can change its data or deduct its landlord balance, but anyone. I'm confused here. Oh, that's good. Sysware accounts are special account that store network cluster state. Okay. Program accounts store the executable codes of smart contracts. Yep. Data accounts are created programs for managed program. Yep. 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 Now, accounts. Every account in Solana has a unique 32 bytes address, often shows as a base 58 encoded string that is gibberish like something is. The relationship between the account and its address work like a key value pair. Yep, 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 yep. Where the address is the key to locate the corresponding on-change data on the account. Yep. This account address acts as a unique ID for each entry in the accounts table. Yep, 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 yep. Okay, so most Solana accounts use ED25519 public key as their address. Use ED25519 public key. What is this for? Okay, so basically, yep, 32 byte address. What is base 58 encoded string? What is this? Most Solana accounts use this and this public key as their address. It's a signature or what? ED25519 is a public key signature system attract with several attractive features. Fast single signature verification, even faster batch verification, very quiet singing, very fast singing, signing, okay. Signing, fast key generation, high security level, foolproof session keys, collision, resilience, no secret array indexes, no secret branch condition, small signatures. So basically the public address, okay, this public address or the public key is base 55 encoded string, but the account which use the edit this public key as their address public key let's rock it, yo, let's rock it. The binary text binary to text encoding format used to represent the public key and the address. Public key and the address in a compact and readable way. It's used 58 character alphanumeric excluding easily confused. Excluding, it says excluding, okay. 10.32 bytes public key, short and easier to share. Is a high speed security elliptic curve cryptography algorithm. Oh, 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 oh. To generate the key pairs, public and the private key, Solana. The public key is 32 byte value derived from the private key, used to identify accounts and verify signature. Our relation to the 82 algorithm then is a public key which is encoded and encrypted. Oh. So what is this here? What is this? Key pair generate them from generating the public key, the secret. Okay, so this algorithm generates the public key as well as the secret key. Correct. Yep. Public key and the private key. Yep. The public is this, the secret is this. Okay. While the public keys are commonly used as an account address. Yep. And Solana also supports a feature called PDAs. Yep. PDAs are the special address that you can deterministically derive a program ID that optionally set. Address that you can deterministically derive from a program ID and optional input set. Okay, so the public key is this, and then program address is this. Okay. This is kind of system program, I guess. And then system program, correct. Now const seed is this buffer from this. Now const PDA and then bump is await public key dot find program sync address sync and this. So if I run this, I got the PDA, this, the bump is 254. Okay, so what it says that PDA are a special address that you can deterministically derive a program ID and option that is set. Okay, so what is happening? It's the program address, and what we are doing is that we are finding the PD and the bump. So if I await this and put it a public key and then find program address sync, that takes two parameter. First is seed, whatever the seed buffer is, and then program address. Yep, address. Okay. That's what it does. Account type is account type max size. Wop. Yep. But what was that? Kilobyte. Maybe bytes. Maybe bytes. Now, every account in Solana has a following fields: data, executable, lampods, owner, brand, epoch. Okay, so I know this. Let's array, a byte array that store arbitrary data for an account for non-executive accounts. This open store that's meant to be read from. For program accounts, smart contracts, this contain executable program code. The data field is data. Yep. Account, that is lamport, data, owner, and then executable, and then brand, approach. Owner is the public key. Yep. Data is factory. Repeat. Okay. Keep here. This is generate new picture. Okay. Connection. This signature. Request airdrop. We have done this earlier. Right. To store data on chain, account must be kept lamport balance that is proportional to the account data stored in the account in bytes. That balance is called rand, but it works like to read the deposit because it can recover the full amount when you close the account, and you can find the calculation here using the constant. Okay. Yep. What it says, that regularly deducted lamports from account that fell below the rent threshold. Okay. The mechanism isn't active anymore. Now the program owner. On Solana smart contract are called programs. The program ownership. The program ownership is a part of the Solana account model. Every account has a designated program as its owner. Every account has a designated program as its owner. Only the owner program can change the account data field, deduct lamports from the account balance, deduct lamports from the account balance. Okay. Got it. So every account has a designated program as its owner. Okay. So basically, if we make an account like a wallet account, then it is designated system program. By default, yep. As I say, by default, all new accounts are owned to system program. Yep. The system program does a few key things. New account creation. Only the system program can create new accounts. Space allocation sets the byte capacity for the data field for each account. Transfer assigned program ownership. Once the system program creates a new account, it can reassign and designated program owner to different program accounts. That is how custom programs take ownership of a new account created in the system program. Yep. All wallet accounts in Solana are just accounts on the system program. As I said, all wallet accounts just on Solana are just account on the system program, and the lamport balance in these accounts are show the amount of SOL owned by the wallet. Only the account owned by the system program can pay transfers. Only accounts owned by The system program can pay transaction fee. What is it? Yep. Now sysvar accounts are specific accounts and predefined address that provides access to postal state data, and these accounts updates dynamically with data about the network postal. You can find full list of sysvar accounts. Why not? Oh my god, Anja. Who's this Anja? I think he's maybe yes. Anja. Is it? This is it. Up for a lot of things. Um, the clock. Now, what I'm doing is here, I'm connecting with this main net, and then found info await connection with gate system account system sysvar clock upkeep. What is written is data type of buffer. What's sysvar? This is this example. Okay, the program account payments. These are the smart contracts. The deploying Solana program creates an individual program account. The program account is stored by using the code of the program. Program accounts are owned by loader program. Oh damn. Program accounts are owned by loader program. That is PPF loader. Program address is owned by PPF loader. Okay, I got it. I got you, bro. I got you. For simplicity, you can treat the program account as a program itself. When you invoke the program instruction, you specify a program account address commonly called the program ID. That means something with the main net, and the program ID is public key. This token, this is the program ID. Correct. And I wanna check the account info of this ID. So if I run this, most probably I'll get this PPF loader as the owner, I guess. And there we go. Who's the owner here? Who's the... Okay, so it is self-owned. So system programs. Program account, this PPF loader over and here in here there's a System program. Okay. Gotcha. 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 Now, now, buffer account. Buffer account. So loader v3 has a special account type for temporarily staging the loading the program during deployment or redeployment upgrades in loader v4. They are still buffers, but they are just normal program accounts. Program data account loader v3 works differently from all other PPF loaded programs. The program account only contains the address of the program data account which stores the executable code. So the program account point when address is program executable data account. What does it say? I don't understand it. What it says. Program data account. Loader v3 works differently from all PPF. The program account only contains the address of the program. Oh, 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 oh. So what it has is that it's a program account and it has the executable to be true, and this program account points to another address that is program data account, and that has the data and then the program code, but it has the executable as false. Correct. Let's see. Program account is a special account. Yep, smart contract. Yep. And marked as executable. It contains the program's bytecode, and it's immutable. Okay. Expect the updates to the addressed account. It is separate account that is stored mutable data associated with the program. Okay. Mutable data associated with the program account. It holds the state of configuration. Data is stored program execution. Each program account can have one or more program data displayed via the program logic. So the program accounts public key identifies the program on the blockchain. The program data accounts have their own public key and are friends by the program account to manage the dynamic data. For example, system programs public keys while it's inside data accounts for distinct keys. Okay, so system program is also program, right? Program account. Yep. They said don't confuse this program data accounts with the data accounts for program C below. Alright, data account. On Solana, the executable code, the program, is stored in a different account. Yep. Then the program state. This is like how operating systems typically have separate files for programs in their data. To maintain state, programs define instructions to create separate accounts that they own. Each of these accounts has its own unique address and can store arbitrary data defined for the program. So um, okay, so what is has the PPF loader is the owner of the program. Yep. The program is the owner of the data account. Yep, 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 yep. Okay. Okay, so it is the program code. This is the program state. So this is probably the immutable one. Okay, like it's like dished. I mean, the build in React or like Node.js is like a build, like you cannot change it, but it is the raw program data. Let's crock. Let's crock it. The program of this account so then actual executable by coding the program. It is compiled for live service now. Does not store the blank state. It holds the program blank state and modifies the program list to modify statements. This separation it separates to the allow the program to manage dynamic data without altering the immutable code. Wait a minute. Hold on. This account does not store the program code. Instead, it holds mutable data like state or configuration, okay, that the program use or modifies during the execution. Okay, so it's like a state management type of thing is happening. It is separated to allow the program to manage dynamic data without altering the immutable code in the program account. Okay, the program account contains the actual code. Okay, not just the build code. The program data account is for data storage. Yep, not the program logic. They are linked with the program's logic with distinct phase 16, 58 recorded public keys. I got you. I got you, my baby. Got you. What's up? I got you, my baby. Now, note only the system program can create new accounts. Only the system program can create new account. Once the system program creates a new account, it can then transfer or assign ownership of the new account for another program. In other words, creating a data account for a custom program takes 2 steps. Creating a data account for a custom program takes 2 steps. Invoke the system program to create an account, then transfer ownership to the custom program, then invoke the custom program which now owns the account to initialize the account data defined by the program instruction. This account creation process is abstracted as a single step, but it's helpful to understand the underlying process. Okay. To connect with this localhost, then get latest blockage. Wow. We sent blockage. connection of the latest blockage. Okay. Be there. So I'm making an account here. Now, what I do is I'll request an airdrop first, get myself some RAM ports, and then sold, and then await the connection, then confirm the transaction, block hash, and then last credit block, right? Cool. Now generate key pair to use as address of command. Okay, so now I'm making a program. Alright, I'm making a program. To create account instructions, system program, create account, public key, new account, public key, this is this, so I'm making this from this space, I'm making a rent account, rent size, the lamp port, the rent exemption, the program ID, student program ID. Now, let's initialize this rent public key, then how much decimal I want to keep, and then the public key of the prepare and the public key of the figure. Correct? Correct? Correct. I'm adding this instruction to this transaction, this instruction, and now I will do an actual transaction, that is this connection class. Okay, so basically this will sign to the adapter, and now I will get into the program in the public key. Okay, okay, hold. Now, huge. We're enjoying it. We're tracking it, man. Okay, now transactions and instructions. In Solana, user sends transaction and track the network. This transaction contain one or more instructions that specify operation to process. The execution logic for the instruction are stored on programs. The execution logic for the instruction are stored in the program deployed on Solana network. For each program defines its own set of instructions. Below are the key about the Solana transaction process. If a transaction includes multiple instructions, this instruction execute in the order added to the transaction transfer atomic. All instructions must be successful or transaction fails and no changes occurs. A transaction is essentially a request to process one or more instructions. Okay, so okay, this is a group of instruction. It is called a transaction, and basically this interacts with the network, the blockchain. The transaction is like an envelope containing forms. Each of these instruction that tells the network what to do. Sending the transaction like mailing the envelope to get the forms processed. Key points. Solana instruction includes instruction that invokes program on the network. Transaction or atomic. If the instruction fails, then every the transaction entirely fails. Now the instruction on the transaction is serialized sequential order. Okay, the transaction size limit is 1232 byte. Okay, each instructions require 3 pieces of information. The address of the program to invoke. Okay, this is important. Each instruction requires 3 pieces of information. The address of the program to invoke, address of the program to invoke, the address of the instruction read or writes to, and extra data required by the instruction function argument. Okay. The count of the count of the account of the instruction reads from, well, let's see here. Okay, so when we sign this transaction, what is it? What is it? Let's talk about an address of the program. Okay, instructions, not the transaction. Yep, yep. Yep, the public key. Let's just needs a public key. Then the account, the accounts, the instruction reads from, and extra data. Okay. The diagram below represent a transaction with a single instruction that transfers soul from sender to receiver. On Solana, vaults are accounts owned by system program. Only the program owner can change the account type. The transferring soul requires sending transaction that invokes the system program. Got you, my baby. So, okay. This time, the sender's wallet signs and sends. What it does is transaction, and it signs the message, and it has instruction to send block slash. Okay. Now, Solar transfer instruction system program. Okay, what is made from this instruction? Is system program is an address from which it like say like the owner, like uh alright, only program owner can change the address of the program. Yeah, address of the program. Yeah, counts the accounts the instruction reads from the right string. That count the instruction reads from. If it accounts this, the transfer sender address, receiver address. Now the sender account must sign this signer. The transaction to make system program protect the network balance and sender in this segment. Address must be writable, is writable since the network balance change. After sending a transaction to system program, the system program process the transaction. The system program then updates the network balance of both the sender and the receiver. Okay, so what is happening here? There's the sender word account info, and there's the receiver that signs and sends. Okay, so it has instruction and has transaction, which is done by system program, and then updates for this. Okay, Okay. Okay. The examples below show how to send the transfer. Another. Yep. Else. Else. Um, so basically, we have an RPC server here. It is localhost, and then we have RPC subscription. Create the Solana script. Okay. Now generate samples and recipients. Okay. Well, it is correct. Solana. Okay. So Lamport console is airdrop factory. Fun server airdrop factory. Takes two parameters as an object. Not this is server and one is the top server. What is specific this is server address. Okay. Okay. And then I get the map code. Okay. So basically I got airdrop. Check the balance of your cash. Now pay balance from balance to server address. Let's see there. Great transfer instruction needed transfer stored for let's let's great instruction. Function is get transfer sold instruction. Get transfer. Transfer sold instruction. Now it takes three. It takes three parameters. That is the source, the sender, and when it send when it is sending it, how much. Correct? So it creates a transfer instruction. Add the transfer string name transaction. Okay, so wait. I appreciate that get its block position and then I type it. Create transaction message. This seems a lot. This seems a lot. This seems fucking a lot. Now, set transaction message PPL signer. Set transaction message lifetime using block cache. Then append transaction message instruction. Oh my god, come on man. Okay. Sends the transaction to the network. Sign transaction. Await signed transaction message with the signer. Then send the confirmation transaction. Get the signature from the transaction. Check the value up to, check the balance up to the transfer. It has a lot of funds in here, which are like insane. Remember those, but we don't chat. Client libraries often abstract the detail of building programs instructions. If the library isn't available, you can manually build instructions. Oh, 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 oh. Client library often abstract detail from the building program instruction. If a library isn't available, you can manually build the instruction. This requires you to know the implementation detail for the instruction. The example below shows how to manually build the transfer instruction. The expanded instruction tab is functionally equivalent to the instruction tab. Okay, so the transfer amount is 0.01. So what I'm doing is I'm getting a transfer soul instruction. Source, destination, and then amount. So I have this soul amount and the transfer instruction. Instruction index for system program transfer index. Transfer instruction. What is this? Instruction index for the system program transfer instruction. Create a buffer for the data to include the instruction. Okay, this seems a bit hard. So I have the instruction data in buffer that is in U in 32 and 64. Alright. Now instruction data dot write U in 32 alley transfer instruction index 0 and then transfer amount into lamp 4. What is happening here, bro? No. Now the system program address is this, and manually creates the transfer instruction. Now once transfer instruction is type of I instruction. I got the program address of the accounts, which is an array of object that holds the sender address and the recipient address. Oh no. No way. You didn't get an instruction data. It's buffer and then I write this 32 array instruction. Zip JavaScript or let's see. Offset is an integer value and it represents the number of bytes to escape before starting to write. And the value of offset lies within 0 to buffer length minus 4 defaults to 0. And buffer length minus 4. Oh. Okay, let's move on. Now, if I select the legacy, right now instruction. An instruction is in Solana on a Solana program can be thought as a public function that can be changed by anyone using the Solana network. Invoking a program instruction requires three key pieces of information: the program ID, the account, the list of account, the instruction needs, the instruction data, byte array, specifying the instruction to invoke on the program and any arguments required by the instruction. Account meta. Each account required by instruction must be provided an account meta that contains pub key, account's address, its signer, and its writable. Okay. So by specifying upfront which account an instruction reads or writes strings that won't modify the same account that execute in parallel. Now example instruction structure. Run the example below to see the structure of soul transfer instruction. So sender, recipient, then lamp or pulse soul, then transfer amount 0.01 soul, then create a transfer instruction for the transfer soul from sender to recipient. This kit is legacy. Like if I want to oh wait, let me say it's using kit and then okay, so I think I would prefer to do it with the legacy. I mean web Solana slash web3.js. So basically it is the keep here generate, and then keep here this, and then transfer from this to this to this. Okay, I got you. I've done this before. Now the following examples show the output of the previous code snippet. The exact format differs depending on the SDK, but every Solana instruction requires the following information: that is program ID, the address of the program that will execute the instruction, and then the account, a list of this is most this is important. I have to write this down. I have to write this down. I have to write this down. Yo, I have to write this down. Solana instruction require the following information. Now the transaction. A Solana transaction consists of a signature and the message. Transaction consists of two things: signature, message. Signature is an array of signatures included in a transaction. Message is a list of instructions to be processed automatically. Transaction. It is a signature and a vector of signature, and it has a message. The structure of the transfer message consists of message header specifies the number of signer and the read-only account. Account address is the array of account address required by the instruction for the transaction recent block hash acts as a timestamp for the transaction and the instruction array of the instruction to be executed. Right, so message has a message header and then a group of public keys, then a hash, and then again a vector of compiled instruction. Okay, header, and then what is it? A, a vector of public keys, and then the hash itself, and then some again vector of instruction. Correct. So transaction has a signature, not a signature, array of the signature or vector of the signature, and then message. And message has a lot of things. Transaction sizes for our transaction have a size limit of 1232 bytes. This limits from the IP for version 6, and the minimum transaction unit MTU size is 1280 bytes minus 48 bytes. For the network headers, 40 bytes. Oh, yep. 48 bytes for the network headers. The transaction total size may stay under the limit and include signatures that are 64 bytes each, and message headers that's 3 byte plus 32 each account case. This block has 32 bytes, and the instruction. Okay, signature maximum of 19 and 64 byte each. Okay, signature 64 byte each, and it could be a maximum 19. And the message has wait. Okay, the transaction consists of two things. Oh, signature and the message. Correct, signature and the message. Signature itself, single signature consists of 64 bytes data and maximum 19 data. And the message, it consists of metadata accounts, metadata accounts, headers, and all of things. So which is header 3 bytes, and account keys 32 bytes, block is 32 bytes, and instructions. Alright. So the message header uses 3 bytes of the define account keys, required signature, and read only sign account, that's why it is 3 bytes. Message header, that is required signature U8. The avalanche employed compactly sectionary item listed for primary. The format is used to encode the length of the account address and instruction array of account address and transaction message contain array of account address required by the instruction required by the instruction. The array starts with the compact section number indicating how many addresses it contains, and the addresses are then coded by their privilege as determined by the message. Alright, now the accounts that are writables and signers, accounts that are read-only and signers, accounts that are writable and not signers, accounts that are read-only and not signers. Okay, so these are our account addresses. Recent block hash. Every transaction required a recent block hash to serve two purposes: act as a timestamp and prevents duplicate transactions. Whoa, whoa. A block hash expires after 150 blocks about 1 minute, assuming 4000 millisecond blocks time. After which the transaction cannot be processed. You can use get latest block hash RPC method. Get to the current block hash and the last block height at which the block hash will be valid. Here is an example of Solana playground. Alright. Alright. Instruction to instruct the transaction message container instruction. Instruction. Like the account address array in the message, it starts with instruction data, its instruction contains program ID and its instruction data. The combined instruction is the program ID index as a U8 integer. save information. Alright, so we have the header. Ha 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 ha. Number requires the signature. Okay, so I guess it is U8 because it is 0 and 1. Okay, so it is not a boolean. It is a numerical boolean. The count keys are these are the keys. Okay. Descent blockers is this, and instruction program index this, account is this, data is this. Okay, okay, okay. I'm getting it. I'm getting it. Bro. I'm getting it. Now when you face the transfer using the signature of sending to the network, you will receive its response with the following structure. Message, then header, message, then header, account case, receive block test, instruction, signatures. Um, okay. Start programs on Solana, writing and updating, verifying, Berkeley, packets, DP. Oh my god. Building program, SPP folder, folder. See all this. And you also you wanna check this algorithm program. Spec 256 Argon program. Insert the core program in Solana. PDS then CPI. Okay, refreshing it.